So when we run one of the tests, our first kind of assumption is that the null hypothesis is true. And when we calculate our p-value, we calculate that p-value as if the null hypothesis is true. So can we draw a picture of what it would mean in this particular example for the null hypothesis to be true? Well, what do I know about the null hypothesis? What is it? 0.75. All right, and this graph we're graphing is of all the possible p-hats, right? If I take every time I take a different sample, those p-hats are going to be all over the place, yeah? What do I know about the mean of those p-hats? Nope. That would be of the z-scores, but of the p-hats themselves, it would be 0.75. If the null hypothesis is true, then the true proportion is 75%. That's what we would expect in the middle. And the standard deviation of those p-hats would be the square root of 0.75, 0.25, and over 100, right? Whatever that works out to be. Perfect. All right, now, okay, you guys, we're saying on this graph, if that null hypothesis is true. If the null hypothesis is true, should I reject or fail to reject the null?
Fail to reject.
Fail to reject. Okay, so the correct decision is fail to reject. Computer? Theirs. It's plugged in the back wall unit back there. Okay, and then if I make an error, that would be rejecting, right? What type of error is that? Type 1 or type 2? Type 1. Okay. And how do we decide whether or not we are going to reject or fail to reject the null hypothesis? We find our p-value, right? And which p-values make us reject the null hypothesis? Really low p-values, okay? And those p-values come from shading, right? Finding the actual sample and shading. In this case, we would shade left because this was a less than question, yeah? All right, so if this were my p-hat and I shaded to the left of this p-hat, would that make me reject the null hypothesis? What about this one? What if there was one right here? Even though it's smaller, it's not like super low probability to be left at this point, or this one. So if I were to ask you where, tell me where to stop, where we might start rejecting the null hypothesis. You guys with me? Hey guys? This tells me we're not all in the same place, yeah? Does anybody wish they would have told me to stop earlier? Let's try this again. Right about here. Why here? Why does this spot say, yeah? It's a small number. Okay. Okay. So that's a p-hat, right? That one might make me reject the null. And this one might make me reject the null. And in fact, anything in here might make me reject the null. Okay. How could we describe that purple area, the part where I reject the null? What is it? If I asked you guys to estimate what percentage that area is, what would you guess? What's our typical value for if we decide if our sample is rare enough? What have we typically used? 0.05? You guys with me? Like, if my p-value is less than 0.05, we use, so essentially, this area here is alpha. Is everybody with me? Because it's whatever that cutoff value is where I need my p-value to be less than it. So if I use alpha equals 0.10, that would be here. Is this cool? All right. So we've done all the hard part. I just want to go back to one thing. So are you guys with me? The purple equals where I would reject. The purple area is where I would reject, and the orange area is where I would fail to reject. Everybody good? And what was the right decision here? Fail to reject? And then what type of error was it? Type 1. Okay. So if, again, we never get to know the actually what's true, but if the null hypothesis is true, the probability I reject it and make a type 1 error is going to be whatever alpha is. That's the probability I get one of the p-hats that's going to make me reject the null hypothesis. Okay, big idea. Type 1 error and alpha are very much related because alpha is essentially your willingness to make a type 1 error. You guys. Remember way back on Thursday, because it's been a long time, right? Okay? We went through and we said in this particular scenario, it would be a much bigger deal to conclude that Miss Lombardi's lying when she's not. Like a type 1 error would be a big deal, right? It was a more serious error to make. You guys remember this? Okay? In this circumstance, we might not want to set alpha at 0.05. We might set alpha at 0.01 because we're more willing to make a type 2 error than a type 1 error. Okay, so if a type 1 is more serious, that means we use a lower alpha. Now, you guys, I'm going to wait till you guys are done writing because I want to make sure we're all like processing what I say next. In fact, I'm going to go get a LaCroix while you guys finish writing. Because, you know, it's fifth period, it's LaCroix time. Okay. Big idea. If a type 1 is more serious, you want to reject less frequently. So you want the boundary for rejection to be a smaller number because you want to reject less frequently. Is this okay? All right. Let's talk about power. on this one. On the one where the null hypothesis is true, because the whole purpose of all of this is we assume that null is true. That's like we're questioning the assumption, but so let's see what happens. That null hypothesis is true, theoretically, and then we say, hey, let's look at what actually happened and could it happen? Are you guys with me? All right, so if I take this picture and I'm letting alpha equal 0.05, there is a value for p hat that regardless of what is true or not true, because that will make me reject the null. There's a value for p hat. We haven't figured it out, but it exists. Because no matter what, as we calculate the p-value, we're assuming the null hypothesis is true. So couldn't we use inverse norm to figure out what is that boundary p hat for where I'm going to reject versus not reject? You guys with me? Okay, so if we do inverse norm of 0.05 with these parameters, that's going to tell us that we are going to reject the null hypothesis, when we are going to reject the null hypothesis. So I need some help. Can somebody figure that out for me real quick? What are we getting for that boundary?
0.68.
0.68, exactly?
Well, 0.678 or 77.
I'm going to do that just because of what I'm doing with this next. Yeah. Okay. Okay. You guys. Let's say she really only beats him 68% of the time. So in other words, now we're going to pretend that p is equal to 0.68. And you guys, if p is equal to 0.68, should I reject or fail to reject? If p is equal to 0.68, which hypothesis is true? The alternative. So in this case, we would want to reject the null and conclude the alternative. So now the rejecting is the correct decision. And failing to reject is a type 2 error. And the center would be 0.68. Okay. All right, I'm going to go back to that previous picture. So are you guys with me that when we set up the test and we calculate our p-value is not calculated on this graph. Our p-value is definitely calculated. So we're going to reject when p hat is less than or equal to 0.678. So, if her actual win percentage is 68%, what's the probability that we make the correct decision? Well, we're going to do that everywhere to the left of 0.678. And can we find this probability? Your first 5 free response questions are going to be like the ones you guys have had all year. I have not given you a question 6 yet. Okay? You won't get a question 6 on one of my tests. Okay? Because they usually ask you to think in a different mindset than what I've taught you. Okay?
I guess when you're talking about how like the big difference between the alternative and the null, like what would like quantify as a big difference and isn't like
So it's the way that would make, so one, if we were going to ask you that question, it's more likely going to be a multiple choice question, okay? And it's going to be which of the following would have the most power. And it might be P equals 0.68, P equals 0.63, P equals 0.52, etc. And and so the further, it's always going to be like, power is always calculated for this very one specific instance where the alternative is true. So for example, it could have been P equals 0.73. If P is equal to 0.73, this test is not going to detect P equals 0.73 very often. Right? And why? 0.73 is just barely under 0.75. But if this was, what about the power if P is equal to 0.5? Then it's definitely going to make the right decision, right? And so it's going to be a comparison, right? So the further that p-value is from that possible value for p, which is different than the p-value, the further it is from that alternative, the more likely it is you're going to reject the null. All right, I'm making a command decision. We're not going to do this question. I'm going to let you guys work on the homework.